All right. A lot of times, as designers, we have to think about three-dimensional things as if we're looking at them in 2 dimensions, right? So if I walk you guys out onto this patio out here, right, you can imagine possibly looking at the plan of those stairs going down, right? And it might look something like this. It might look, there could be a platform here, and then a bunch of lines going this way, right? And then there's a big platform here, and then more lines going this way. And it's actually not that wide, so probably say about there. And isn't there a wall out here? At the end of that staircase, isn't there a wall? No? Yeah?
Outside?
Outside.
Yeah.
Staircase outdoors. There's a big wall there, and it's got a hole right in the middle, right? So maybe what that might look like this. With a little hole right there. Yes? And then we got handrails that start here and they go down this way. There's a rail here that goes down and it turns the corner, and then there's a railing all along here. Right? So that's kind of that's a view of a three-dimensional object, but we're looking at it from straight up above. So one of the ways to kind of think about that is going to be to establish how far above the ground something is. So let's just say that we're using the concrete down here, right, as 0.0, so 0 feet. And let's just hypothetically say that the landing right outside the door, right, when you go outside, is at 15 feet. So this is at 0 and that's at 15 feet. Just to make it really easy to do the math, we're going to say that the stair treads are 6 inches. Okay? Because everybody can say that 6 and 6 is 12, and 4 times 6 is 24, which is 2 feet. Let's just say that. Okay, so if this is 15 feet, and I step down one, what's my elevation here? 14 foot 6 inches. And this elevation of the next one? 14 foot 0 inches. And the next one? 13.6. And then you do that going all the way down to get to 0. Right? I didn't count the number of risers, or I could get this exact. So do you guys understand that? Does that make sense? Simple, right? Okay. We're going to do something very similar with our corridors and our rooms. We're going to think of the corridors in 2 dimensions, okay? And we're going to think of the stairs as going in 8-inch increments, okay? That's what your program, your paper says, is 8-inch increments, right? With a 12-inch tread, I think it said. I think so. Who's in Marty's class? Anybody in Marty's class? You guys are already working on stairs. I saw it this morning. Those of you that are in Jeff's class, are you working on stairs yet? No? Okay. Hopefully Jeff will start working on stairs. So I'm going to erase, I'll leave this here for reference, and I'm going to use, again, this young man's example right here. Efren? No. What's your name?
David.
David. I'm going to use David's example right now. I'm horrible with names. I got You are working on stairs in Jeff's class. Okay, good. So, all right, what I'm going to do is I'm going to take a look at David's plan right here. So if I look at David's plan, he's got a corridor that's going this way, right? And that corridor is 8 feet wide. It's actually a little longer than that, so we'll go this way. Right? And it has walls all the way around, so I'm going to go ahead and draw the walls. Does that look about right for if we took a slice through the middle of the corridor? Yeah? Okay. So now he's got these rooms that are attached to it. And somehow, some way, we've got to get from the elevation of this, right? So I'm going to say that this is up at, 2 foot 8 inches of height. Okay? That's what your contours are. Each contour is 2 foot 8 inches. And now we've got to get down, right, to the bedrooms that are now down at 0. Okay? So how do we do that? Well, for starters, one of the things that has to happen is that those bedrooms are going to have to interpenetrate into the corridor. Now, you only have 8 feet on the inside. Okay? So, again, this is some of the math that you have to do. How many minutes?
5.
5. Okay. So, unfortunately, there is not a whole lot of really high-level math in architecture and design, but there is some basic arithmetic. So, if my walls are 8 inches thick, that's what the prompt says, 8 inches, is that right? How much space do I have left inside the walls? Someone do the math. Who's got a calculator? Who's got a phone? Liars. Y'all have phones.
6 foot 8. Yeah.
6 foot 8?
Yeah.
Okay, I believe that. That sounds about right. 6 foot 8 plus another 16 inches, right? Which is 1 foot 4. So 6 goes to 7, and 4 plus 8 is 12. Is 8, right? So you got to get used to adding feet and inches. Okay, so we've got inside dimension from here to here is 6 foot 8 inches. Okay, all right. So in order to get from this level down to 0, we need to have stairs. And the minimum width for stairs is 3 feet. So that means that we're going to have to take our bedrooms, and instead of placing them on the surface here, because this is what we currently have, right? If we look at his, that's what, they're not interpenetrated yet, right? We have to get them to squeeze into each other. So what really has to happen is it's got to pop in here. And it's going to have to pop in here a certain distance. Anybody want to take it? Let's see if we can't get somebody to tell us. How far in does this have to go?
2 feet.
Nope. If it goes in, so 2 feet from where?
From the outside.
From here to here is 2 feet?
From the outside, you go in 2 feet.
So from here
2 feet
to
in.
here is 2 feet?
It should be 2 feet, or it should push in 2 feet from the outside.
Nope. How wide do stairs have to be?
3 feet wide.
3 feet. And we're going to have to put in stairs right here. Right? Because we've got to get down to this level. So, all right. So, oh, wow, 3 feet. So this is 3, right? Oh, that makes a big difference. So it's 3 feet plus 8 inches plus 8 inches is what? 4 foot 4, right? So we've got 36 inches. That's 3 feet, right? Plus 8 for this wall and plus 8 for that wall, right? So 8 and 8, 16 plus 6 is 22, right? And then 3 plus 2 is 5. 52 inches.
So from the outside, you have to push your building in 52 inches.
From the outside to the other end of the wall, 52 inches. And we had to do that with math. Really basic arithmetic, but it's still math. See, this is why we say that architecture is for engineers that don't like math. Because the math is usually pretty easy. Right? This is really, really easy. Is it like, so are you guys following along with this? Do you guys understand the logic here? Do you understand how it is that you have to take this in step-by-step fashion? Notice that Tamara threw out 2 feet. Now, this is a really important thing about design. Okay? Sometimes you just have to make a freaking assumption. 2 feet. All right, let's test 2 feet, see if it works. So we started testing and it's like, oh, wait a minute. We're not going to have enough room for the stairs. which are 3 feet. So you see what's happening? That process of putting out a hypothesis and then analyzing it is called critical thinking. It's a low level of critical thinking, but it is critical thinking. You are having to make decisions and discover whether something will or will not work. This is one of the things that makes designers such valuable employees, right? That they are not robots. Through the process of their design education, they become critical thinkers. You have to. You don't have a choice. You have to become a critical thinker. Okay? All right, so we've come to that conclusion. How many minutes am I at?
10, almost 11.
All right, let's stop it.